All right, folks, I want to tackle this next question. This is taken from page 119 of the textbook, question number 12. And this is a good question because it's a tough one and it deals in 3 dimensions. So let's get right at it. It says here that we've got a building. It's in Wascana Park, and it has a tower, a dome tower that's center. And it tells us that Janelle stood 40 meters from the tower, and very important here, it says due south. And it's from a point directly below the dome. And from her position, she has an angle of elevation to the top of 53 degrees. We then have a second person who stands due east of the tower and measures an angle of elevation to the top of 61 degrees. So the questions then become, how high is it to the top of the dome? How far is Troy, the second person, from the dome, or directly beneath? And how far are Janelle and Troy apart, giving the measures to the nearest meter. So if we're going to draw this, one of the first things we have to do when we see east and south or compass directional points is we should draw in what's called a compass rose. And I just labeled it northeast, southwest. I also have it slightly askew just for visual purposes. I'm placing this dot here as going to be sort of an up position. So this is going to the very top of the tower. And I'm going to just quickly draw in a blue triangle here. This triangle represents, first, this side is how tall the dome is, how high up it is. And then this one line right here is how far away Janelle is. So let's just label it. This is 40 meters here. We actually don't know how. The first question is asking how high the dome is, and that's really what we're going to try and tackle. And we also have an angle here of elevation of 53 degrees. And that's right here going up. We also have a second piece of information because we've got Troy, who's going to be over here somewhere, due east of the dome. We don't know how far away Troy is, but we do know that he has an angle of elevation of 61 degrees. So if we can figure out how tall the dome is, that is going to help us figure out how far away Troy is. And then we can move to working on the third problem, which is how far apart are they? Now, one of the neat things about this is my horrible little drawings here. These set up as 3 right-angled triangles. The distance between them, where they stand, and the top of the dome. It looks kind of odd, but really this is a 3-dimensional shape. And I'm going to call this D is the distance between them. So let's get to work. So for the first part, A, how high is the top of the dome? This sets up as a tangent ratio, where I have the opposite side from my angle, which is the height, and I have the adjacent side, which is how far Janelle is from the base. So for A, I set up as the tan ratio, or tangent of the angle, or tan of theta, is equal to opposite over hypotenuse. And just for the sake of argument, I'm just going to say let h be the height of the building. So that means the tan of 53 degrees is equal to h, or the height, divided by 40 meters. To solve that, I'm going to multiply both sides by 40 meters, and that will give us how tall the building is. So 40 times the tan of 53 degrees, and I get the height, or the opposite side, is equal to 53.08 meters. So the building is 53 meters tall. Now we're going to figure out Troy. And it says, how far is Troy from the dome? Well, now that we've got this piece right here, we can use the opposite and the adjacent to the angle 61 degrees to calculate how far away Troy is. So if this is 61, so we'd fill in for the angle 61 degrees, and we know that the dome building is 53.008 meters tall. So we could say the tan of 61 degrees is equal to 53.08 divided by x. So, and x would be how far away Troy is standing. So we end up with x times the tan of 61. So basically what I'm doing here is I'm multiplying both sides by x. So these cancel, giving me x tan 61 degrees is equal to 53.08. I then divide both sides by the tan of 61 because I'm trying to isolate or get x by itself. And I divide this by the tan of 61 over here. And I find that x is 29.42 meters. So what does that tell me? That tells me Troy is 29 meters from the dome. Great. I've finished the A and I finished the B. Now I just have to figure out how far apart are Janelle and Troy. Well, if we look at our triangle here, this is a right-angled triangle as well. How do I know that? Because I'm talking about due east and due south, and compass points of east and south set up as 90 degrees. I have a side of 40, which is what was given to us in the question, and I've just calculated that Troy is 29.42 meters away, so now I have both legs of a right-angle triangle, and that means our old friend Pythagoras. I'm going to call this J and T because Janelle and Troy. You could have used X and H or X and 40 and come up with some other name. I'm going to use J and T simply because that's the names of the people we're working with. And I fill in the values. D squared is equal to 40 squared plus 29.42 squared. It's better to use this value here than this rounded value, just for accuracy's sake. More decimal places used, the better. I square both of these. D squared is equal to 2,465.5364 meters. It's here. I add them. Don't forget, because I'm looking for the hypotenuse here, not a leg. And I then take the square root of both sides. I'm left then with the distance between both Janelle and Troy is 49.65 meters. And I finish with a nice sentence that says they're about 50 meters apart. There's a lot in that question. If you have any further questions or need clarification, you can send me an email or check with me on Google Classroom. Good luck tomorrow.